the energy transferring depends on the temperature difference. Okay, and such kind of energy transferring introduced by the temperature difference is called heat. Okay, so if you have some material, if you put it in a hot environment, the material should be able to absorb heat. So the amount of the energy absorbed during the process depends on, you can think about that, depends on two things. Okay, the temperature difference and the property of the material itself. Okay, so if you if you put some object in a 100-degree environment, compare with 10-degree environment, Celsius here we're talking, okay. Say this one itself is 5 degrees. So of course you can imagine, if you put it in a 100-degree environment, it will absorb more heat, okay. Put it into a 10-degree environment, it will absorb less heat, okay, because it can provide more energy to this. The temperature difference here is 95, this is 5. So that's delta T. It will affect how much heat you are going to absorb from the material. But it also depends on the property of the material itself. If you put an iron or if you put a wood, it will make difference. And so say what happens is that if you put two different objects, both of them are 5 degrees, and you put them into a 100-degree environment. If this is material 1, say iron, this is material 2, wood. Okay, they will absorb different amount of heat. And so if some object will absorb more heat, we say that those objects are capable of storing more heat energy. So that's why I say there is something called the heat capacity. So the ability to store more heat inside of, more energy inside of the object. Okay. We use a capital C here. So the heat absorbed during the process equals to the heat capacity multiplied by delta T, or T final subtract T initial. Okay. And here, the capital C is called the heat capacity. Again, it depends on two things. First, of course, you can think it should depend on the size of the object. For the same material, if this is iron, this is also iron. Larger size iron or larger mass iron, of course, will store more energy inside, right? So we can further write the heat capacity as mc. Here is capital C, here is a small c. M is the mass of the sample, of the small c is the specific heat capacity of the material. Sometimes we simply say specific heat. So what happens is that if they are the same material, they will have the same specific heat. So all the iron will have the same specific heat. And different sample will have different heat capacity because it also depends on the mass of the sample. Okay. So capital C, the heat capacity, is a sample dependent quantity. And small c, the specific heat capacity, is only a material dependent property. Okay. And they are related by the mass of the sample. So heat can also be written as mc delta or mc T final subtract T initial. Okay? This is more useful for us because we have some table to give you the specific heat capacity for all kinds of material. And then you just need to measure the mass of that your particular sample, and then you can use this equation to calculate the heat absorbed by a particular sample. Okay. Now, if you look at this equation, M mass is a positive quantity. Specific heat, small c, is a positive quantity. But this one is a subtraction. So it depends on the final temperature and the initial temperature. You may have positive or negative value for this quantity, right? So the heat after the calculation can be positive and negative. So we need to understand when you have a positive heat or negative heat, what do we mean by that physically? Okay. Physically, it means that so all the heat, no matter how we would like to calculate, there are many different equations to calculate the heat for different processes. But it's always like this. If you got some positive heat, that means the object, the sample you're talking about, absorb the heat. Okay, so the heat is absorbed into the sample to increase the energy of the sample, internal energy of the sample. If you get some negative value, that means the environment extracts the heat from the sample. Okay, so or in other words, it's the energy release from the sample. Okay, so positive value means energy absorption. Negative value means energy releasing. Okay, this you need that's something you have to understand, because for some equation you have to determine the sign by such kind of analysis. For this one, of course, it's not a problem. If you can do the calculation, it will automatically give you the positive and negative. But sometimes you have to determine it by yourself. Okay, so energy releasing, negative, energy absorption, positive. Okay? Okay, by the way, the unit of the heat. In the history, there are some specific heat units, some particular specific unit for the heat is called the calorie. Okay, that's also used in the food nutrition. But in fact, if we understand the heat is simply some energy transferring, so we understand for the standard unit, we simply need to use the energy for the energy. Okay, the unit for the energy, which is joule. So in the scientific study, we are going to use the joule for the unit of the heat. Okay, because heat is nothing but the energy transfer. Please note that work, by definition, is also another kind of energy transfer. Okay. So the work, heat, and energy, they have the same unit. Okay. Okay. One more note about the heat capacity, or the capacity, specific heat capacity, is that here we say that it depends on the sample. Okay, it depends on the material. In fact, it also depends on the process. So for the same material and different process, you may even have different specific heat capacity. Okay. So like for the gas, if you try to consider a gas, you can have the specific heat of a gas under constant volume process, specific heat of a gas on constant pressure process. Then to distinguish them, usually we need one subscript. So for small c of the gas, you have Cp and Cv. Cp means the specific heat for the constant pressure process. Okay. Here P means constant P. Cv means the specific heat of a gas at constant volume process. Okay. So for the gas, usually you need to talk about the difference between Cp and Cv. For the solid and liquid, usually you don't have to make the distinction, because for those kind of material you cannot even compress it, so there is no difference between the constant pressure process and constant volume process. Okay, but for the gas there may be difference. Okay, but that's something you just need to know here. We are not going to do the detail about these different specific heat. Okay, that's how can you calculate the heat absorbed by the material. Okay, and